The example will show you how to understand and graph the polynomial function given the example. Solution. After this function, here is the step. First step is we have to find the degree of the polynomial. Now, if you look at the example here, this factor here has a degree of 2. Then you time another x, which is now you have a degree of 3. Then you time another x when you foil everything out, so therefore you have a degree of 4. So our n, the degree here is 4. Okay. Now, if the degree is 4, the maximum number of turning point I think I spelled the turning point wrong. Did I spell it wrong? Point is n, which is n minus 1, which is 4 minus 1 equal to 3, our maximum turn. Now, it's also good to know the behavior of our graph, the end behavior. So the end behavior our A here is 1, so it's positive. Since our degree is 4, that means I have 2 arms go up at the end. So this is our end behavior. That's 2. Now find the 0 of the polynomial. Now remember, the 0 of the polynomial is just the same thing as the x-intercept. So if you let f of x equal to 0, I have x plus 4 square, x plus 1 square, and x minus 2 square. So I have x plus 4 square equal to 0, or I have x plus 1 equal to 0, or I have x minus 2 equal to 0. So let me put it like this. X plus 1 equal to 0. Then here I have x minus 2 equal to 0. Over here, you solve for x equal to minus 1. So that is your x-intercept or the 0 of the polynomial. Right here I have 2. This here means x plus 4 times x plus 4 equal to 0. So when you solve for x equal to minus 4, you have x equal to minus 4 twice. Because when you solve, it's all the same. So we keep only one minus 4. So right here is the 0 of our polynomial. Okay. Our next step is determine the multiplicity of this 0. Now, the multiplicity of this 0 is twice, because I have minus 4 twice here. Or this 2 here also tell me to have twice. The multiplicity of this 0 here is 1. Right here, our multiplicity here is 1. Because our solution only repeat only one time here. One time here. I have only one solution for x equal to 2, only one solution for x equal to minus 1, 2 solutions for x minus 4. The multiplicity means how many times this 0 repeats itself. So you have twice, once, and once. So here we write down 2, 1, 1. Okay. 4, we determine whether our graph crosses or touch at our solution. Because our multiplicity here is even, even here is 2. Therefore, the graph touches the x-axis at x equal to -4. Now, our multiplicity is odd, so therefore the graph crosses the x-axis at x equal to -1. And same here, because our multiplicity is odd, therefore the graph crosses the x-axis at x equal to 2. Okay, that's how we analyze our graph. Now, if we want to graph this here, it's pretty easy. Okay, it's always good if you want to know the y-intercept, because we know the x-intercept. So let's say I want to find a y-intercept. Y-intercept at x equal to 0. So I have 0 plus, here's my problems, 0 plus 4 square, 0 plus, right here I have plus 1, and then I have 0 minus 2. So you see I have 4 square times 1 minus 2. So I have 16 times minus 2 is minus 32. That is our y-intercept. So let's see how we graph this. Okay. So first we plot our solution, or this means our x-intercept, which is right here, and we also x equal to -1 and 2. So here's -1 and here's 2. So this is our x-intercept. We know that our graph, the end behavior is open up to open up. So that means at the end here, our graph go up like this. Okay, wherever in between we fix it. Now we know that when x equal to -4, our graph touch, because even, so our graph touch at this point. So at this point here, our graph touch this way. So I have two possibilities. I can touch this way or that way, but my arm is go up this way, so my best is our graph touch this way upward. So draw it nicely. So we have our graph touch the point at x equal to 0. There you go, it touched the point. Okay. And we know our graph crossed as x equal to -1. So there, one would cross x equal to -1. This way, down this way, or I can cross that way. Now our graph somewhere here, somehow it go up here, and go down, and it cross over x -1. So our graph have to cross this way, approximately. Right here, it is approximation. Then, we know our graph also crossed when x equal to 2. So, but we know that our arm has to go up this way. So the two ways to cross the x equal to -2 is that way to join this arm, or this way. this way is impossible because I have nothing down here. We know at the end our graph go up this way. So therefore it has to be cost this way. So our graph cost like that. So now our graph will cost this way, go down, cost at y-intercept, and eventually go up and cost at at 2, because we know that our graph cost is 2, and then go up that way. So that's our graph right here. I'm doing approximation here. So roughly our graph will look like that.